So the new chapter is a very small chapter. Well, because I broke it up into two parts. It's pronounced polynomials. All right? And you may have sort of heard this word before in your science class, right? Poly, right? In science, chemistry, right? Poly, you heard the word polyatomic. And the word poly just means many, right? And now we just got to figure out what are nomials, right? All right, so we're working with many of these things called nomials, all right? So I broke this up into two parts. You can notice that the package I gave you today is quite thin, right? So we may even be doing the test by next week, right? So there's only 3 lessons in this, and students often do very, very well in the first half of polynomials. If you can memorize some vocabulary, and if you can add and subtract numbers, you will be fine. The second part is hit and miss, depending on the students. Once again, not a big part. It's another 3 or 4 lessons, right? So another 2 to 3 weeks, right? So this chapter or these 2 chapters go quite quickly. So if you have some absences planned, you're going away on a tournament or something like that, or you have a vacation and stuff, make sure you stay on top of it, right? Because chances are when you come back, we'll be at the end of the chapter, or maybe you've done the test, right? Because they're just so small. All right, so let's get going. Have your name. We are block 4 of day 1. All right. So today, we're mainly just going to look at vocabulary. And next day, we'll start getting into the math behind what are these things called polynomials, right? So, a polynomial is made up of many things that are called terms, right? And you're going to notice lots of X's and Y's and Z's, lots of letters in here. So don't get nervous about it. Remember, a letter is just a number we don't know yet. So that's what letters are, unknown numbers, right? So we're going to see it. This year, we're not going to use those letters too much. Maybe 1 or 2 questions. We're going to learn how to work with these X's and these Y's. In the years coming up, you'll actually start plugging things in for X's and Y's and stuff like that. Right? All right. So now, terms are connected by adding symbols and subtracting symbols. So by addition and subtraction. Symbols. Okay? That's what our terms are connected by. So a polynomial is what we're going to see here. And one of the things that you need to be able to do is look at an expression like that and tell me how many terms there are. Right? So we said terms are separated by pluses and minus signs. So usually what I do is makes it easier for students. I highlight these and I can go, okay, they're separated here and they're separated here. How many chunks are there? That's how many terms. Nope. There's 1, 2, 3. This has 3 terms. Okay? So the number of terms an expression has tells you what the name is. So you need to go count how many terms there are so you can name it. Right? So if something has 3 terms, it's called a trinomial. Like this. Right? So there's 4 names you gotta memorize, right? One of them is trinomial. That's for something that has 3 terms, right? The other one is, hey, what if it has 2 terms, right? So here I got my subtraction. I split this here. I got 1, 2 pieces there. And if it has 2 terms, it's called a binomial, right? And if it has no terms, no pluses or minuses separating anything out, sorry, it has one term because there's no extra pluses or minuses anywhere. It's called a monomial. Okay, so you have to memorize those three names plus one more. Right? I don't know what's going to work for you memory-wise. For me, I sort of try to think of like a bicycle. Bicycle has 2 wheels, 2 terms. Tricycle has 3 wheels, 3 terms. Only thing that analogy kind of falls apart is with the one-wheeled cycle. It's called a unicycle. That's a monocycle. So you got to figure out a way to trigger these memories. I like to think about bikes, and that's sort of how we grew up. But whatever works, right? So now, technically, there are names for however long of an expression you can come up with. 4 terms, 5 terms, 6 terms. There's names for all of them. For the purposes of grade 9, you only need to know up to 3 terms. Now, after 3 terms, we use a generic term called polynomials. All right? So if it has more than 3 terms, like this one here, we split here, we split here, we split here, we split here, you got 1, 2, 3, 4, 5 terms, we're going to say polynomials. Now, technically, all of these are called polynomials. You can use the phrase polynomial for the binomial. You can use it for the trinomial. Right? We're going to be specific for the 1, 2, 3 terms, and it will be generic for anything more than 3. But technically, the word polynomial fits. So if I give you a quiz, I will mark you wrong if you wrote down polynomial there, even though technically it is a polynomial. I want to see the word binomial here, and I want to see the word trinomial here. Right? All right. So let's practice this. All right. So here we got a bunch of expressions. We're going to quickly go down the terms here. And say how many terms there are in each one of these expressions, then we're just going to do the naming thing. So this one to begin with on the top, how many terms do we see there? Just 1. All right. Next one, going down, how many terms do we have here?
3.
3. Split, 1, 2, 3. All right. Next one with the y. 2. We split at the minus. Then you have a term, there's 2. All right. The next one going down. 2, thank you. We split at the minus, term, counting, there's 2. All right. Next one.
1.
Just 1. There's no plus or minus separating anything. The last one. 3. Split, 1, 2, 3, 3. Okay? So now, that's the hard part, the execution of counting terms. The other part is just memorizing. So look on the left-hand side, what is something called 1 term called? What is something with 2 terms called? Right? That's just connecting the things. Right? Monomial, trinomial, binomial, right? So fill in those, right? So using our legend over here, right? And that's it, right? So I will be giving you a quiz. I'm hoping next class if we can get through our notes and do our assignment. Our notes aren't very big, but we'll see how long things take here. All right? And one of the questions will be, just tell me the name of this. All right? So do not be lazy and just write down the word mono. You have to give the full name, monomial. And typically, I will give you the spelling for this. So you don't have to worry about the spelling too much. Like here, I have the spelling right in here. So for most of the times, I will give you the spellings of all these kind of polynomials. Right? But I think you'll have them memorized.
Monomial is with O, but the first is O.
M-O-N-O. Okay?
Thank you.
All right. Next one is called, what is this one called?
Trinomial.
Sorry?
Trinomial.
Trinomial. Thank you. The word tri, right? Then the nomial. Right? Next one, there's two of them, right? So binomial, and so forth, right? Pretty straightforward, right? Bi, mono, tri. Okay. So now, the next thing you need to know is a term called degree. Oh, good. Okay. So now, in grade 9, all I teach you is how to figure out what a degree is. It's going to be like 1, 2, 3, 4, 5. It's going to be a number like that. That's all you need to do. In future grades, you need to work with them. So I'll kind of connect what it's supposed to be. The next little part you don't need to know. So a degree tells you the characteristics of the graph. So all these are expressions, we can graph it, right? So by looking at it mentally in my mind, I know how that thing's going to look like. If something has a degree 1, the graph is going to be a straight line like this or like this, right? If something has a degree 2, it's going to go like this or like this. If something is a degree 3, it's going to go like this, and it's going to go like or like this, right? You notice the left and right side are just mirror images of each other, right? That's where this is heading. You're going to be able to draw sketches of these graphs, and those are rough sketches. You will tell me how steep it is, how narrow it is, and right now we're just learning out how to figure out what the degree is, right? Okay, so how do we figure out degrees? So we look at every single term that there is, and what we do is we add the exponents of the variables. Okay? So in this box over here, I've only got one term each, right? So it's a little bit easier. So we look at the variable. Remember, the variable is the letter. So we look at the letter and you go, okay, what's the exponent for that letter?
1.
1. Remember, if you don't see an exponent, there's an imaginary 1. Right? So this has a degree of 1. Right? There's only one exponent, so there's no adding to do. If you have more than one exponent inside a term, that's when you start having to do adding. So for example, in the next one down, we have
3.
X and a Y. So we have to add the 2 and the imaginary 1 that's there. So this one has a 2 plus 1 has a degree of 3. Okay. The last one,
0.
0. There is no variable, right? So this has a degree of 0. Now that one I didn't show you the graph of, but degree of zeros are called constant graphs, and those graphs are just a horizontal line. The value is always 12. So you can imagine that one in your head. It's always going to be a straight line, going like that. Okay, so that's how to find the degree of a single term. Now, if we have a polynomial, it's made of a bunch of terms. So what we need to do is find the degree of every single part, and then the degree of the polynomial is whatever the part is the highest. That one is the most overbearing part of the polynomial, so that's the characteristic of the graph that it kind of overtakes. So we go like this, we go, okay, this one is broke up into how many parts here? How many terms? 3. You go split, split. There you go, okay. First part here on the left-hand side. What's the degree of this one?
2.
2. All right. The degree of the middle part?
1.
1. The x has a 1. Degree of the last part?
0.
0. So now, we don't add these numbers together. We go, hey, the most overbearing characteristic is going to be the 2. That's the biggest number. So we take the highest one. That's going to be 2. All right? So you'll get really good when you get to higher grade to go, okay, I can spot the highest term. I know it's a degree 2. I know it's going to be a graph that sort of looks like one of these two. All right? All right. So let's practice that. Okay. First one, only one term, right? So the degree of the polynomial is the same as the degree of the term. What's the degree here?
2.
2. We look at the variable. Oops. We go 2. Okay. Next part.
2.
All right. Before we do that, Ty. How many parts are there, Ty? ABS. This one here. How many parts? 3. 1, 1, 2, 3. All right. What's the highest degree? 2. That's the middle one. This one has a degree 1. This one has a degree 2. This has a degree 1. So the biggest one is 2. Okay. So I'm asking you the same questions. How many parts are there? How many terms are there?
2.
2. All right. What's the degree of each part? 1 and 0. What's the biggest one? 1. The degree of the polynomial is 1. All right. Next one. How many parts?
2.
2 parts. Degree of the first part?
2.
2. Degree of the second part?
2.
2. We have a 1 and a 1. We add those together. We get a 2. What's the overall degree? 2. So there can be ties. If there's a tie, you just pick the tie, whatever the highest one is. Right? All right. Next one, R. What's the degree here? 1. There's only one term. The R has a 1. Right? There we go. All right. Next, we're going to split this up. 1, 2, 3 parts. What's the degree of the first part? 2. Second part?
1.
1. And
0.
0. Overall degree?
2.
2. Okay? So none of this is difficult. The hard part is keeping it straight in your mind. Getting the vocabulary memorized and go, okay, this is what I gotta do here. And so all you're doing is counting and adding in this specific case. All right. Next one up. So now, unfortunately, I don't use the word unfortunately because I don't like these things. You're going to come across picture versions of these expressions. I don't use them very often because I think most students actually do better just with the expressions themselves. However, wherever your teacher next year is, or on a test somewhere, you may come across picture versions of expressions. So I have to do my due diligence here and just show you how they connect up. Okay. So here we have big boxes, little boxes, and rectangles. This picture here means the same thing as this. By looking at the two, could you guess what does each symbol mean?
Yes.
What does a big box mean? What does a rectangle mean? What does a little box mean?
Big box is 10 maybe?
The big box, so if you think this is 10, where do you see the 10 up here? Nowhere, right? So a big box, sorry?
The X would be the 10.
You're getting there, right? So these are referring to the variables, the x's or the y's and stuff like that. So here, on the first one here, we have two of these big boxes, do you think if you split this up into terms, right? If you notice, there's three shapes, we have three terms. What term do you think this big box represents? Does it represent the 3? Does it represent the 4x? Or does it represent the 2x squared?
The left one.
The left one. So big x's are called, big boxes are called the x squares, the squares. Okay? Square for square. All right? And we have two of them on this one because there's a 2 up front. Right? So if we wanted to draw the picture of it, we need to draw two of them. This is two boxes. Right? So now, next one, we have 4 of these. All right? What is left over here? What could they represent?
Middle one.
Middle one. So these represent x's. We have 4 x's. 1x, 2x, 3x, 4x. Add them all up together, we have 4 of them. Right? And that just leaves the last little one. So the last little one, the tiny little boxes, just are like going back to like grade 7 and elementary school. Each little box is just 1. So that represents your whole number. Right? So we have a 1, and a 1. So altogether we have 3 of these. That's just your whole number. Okay? So without really me telling you, you know what each symbol represents. All right? Now, there are some black shapes, there are some white shapes. There's a color difference. Why is the middle one chosen to be drawn in white instead of black? So, honey? Because it's negative. If you noticed here, this number here is a negative number. Right? So white, a white shape is a negative number. A black shape is a positive number. Okay? So if this was negative 2x squared up front here, we would draw these big boxes as white. Right? But it's positive, so we draw it in black. Okay, so now you don't need to write that down because on the back side, I have a legend here for you. Right? So on the back side of the page, we have 1, and you have an x. So this stands for 1, this stands for x, this stands for x squared, and the word positive and negative is there. Okay? So we're going to practice using these things. So over here, we've got different pictures of different expressions. So in your mind, you go, okay, how many terms are there? And what are those terms? So the first one, A. How many different terms are there?
2.
2, because there's 2 different kinds of shapes. There's a rectangle and a little square. Right? And if you want, you can draw your little split here. Okay? All right, so we're going to have 2 parts separated by a plus or a minus. The first part here, what is this?
Negative x.
Negative x, a rectangle is x and it's white, so it's negative x. So this,
And positive 3.
negative x, and this is 3, and so we have 3 of them. They represent 1, so they're positive 3. So we can write down a 3, but we need to put down a plus sign because we need plus and signs and minus signs that separate out the terms. Right? So in your mind, how many terms do I have? And then write out what the terms are. So the next one, B. How many terms are there?
2. 3.
3. So there is a separation here and a separation here. So we're going to come up with 3 terms. A term, term, term. Right? So just go from the left and you work your way across. So first term.
X to the exponent 2.
X to the exponent 2. Okay. Next term. So big box, x squared. Okay. Rectangle. What box? What shape? What does it represent?
X.
X. All right. And then the white little boxes.
2.
Negative 2. Minus 2. So now, once you write that down, just go back and have a quick look. Is every single term separated by a plus or minus sign?
No.
No. We're missing something here, right? Right here.
Yes.
Since this is positive here, we need to put up a little plus sign in there. That's it. Okay. Try the next one by yourself. All right? I'll help you out. All right? There's 3 parts. And try actually the next 2. There's 2 parts in C and D. Give that a try. And you come up with what the expression is. All right. You got it?
Yes.
Let's go. Nicely done. Nicely done. Good. Yeah. Yeah. Okay, so that's definitely an x squared. Well, there's 2. So it's minus 2x squared. You don't repeat x squared twice.
Oh.
There's 2 of them. So you go negative 2x squared. Good. That's it. Come on, Mohammed. Give it a try, man. You can count. Right?
It felt like we ran the track.
Gymnastics.
On the right page. So we just did the one last week. Come on, these are
Like right away.
okay. So these are should we always squares or not? Good. Yeah.
Never seen that in my life.
These are white.
I don't know what. Oh yeah, because we put the like a block that place.
Good. There is 2 of these. Right? There's 3 of these, good, but you lost your x. Minus 3x. Right? And now we just have plus 1. Just wait until we don't notes. So 2 of these. One box for x.
And you get each.
And there's 3 of them, so we can 3 in front and
Oh yes.
right? Okay? 2 of these big boxes, 2 okay? Good. Hi. Good. That one's good, this one's good. Yes. These big boxes are squares, x squared. Other than that, you're good. Okay, let's see.
No, I just like forgot so much. There's no ending.
Okay, your answers just like that. Most people got it. Some of the mistakes I noticed walking around. The exponents. They're either going to be a square or just an exponent one that you don't see. The number has to go in front of the x. Right? Some people put like, oh, the 3 behind it. So the order of it matters. Right? And I think after, the day 2 assignment, I'll explain how degrees sort of get used a little bit more. I'm not sure if I'm ready to teach you that. We still have like a half an hour left in class. So I can give you the assignment. It's tiny, right? You'll go quickly through it. And